Okay, good afternoon, guys. We're doing polynomial division in our college algebra class today. We're doing section 5.4. Homework assignment, page 400/418, 1 to 53, every other odd. This section is one of those that if you are struggling with like the basic skills of like multiplication, division, addition, subtraction, this section just is brutal. Just absolutely brutal. Okay? It's mainly because if you don't have a firm foundation in how to add, subtract, multiply, and divide, then trying to do it with polynomials is it's just painful. It's hard. I can't express that any other way. So to showcase kind of how this process works, I'm going to showcase some of how your book does it by looking at a previous topic, division of numbers, and then showing how that relates to polynomial division. So first of all, let's define some things here. Number one, remember a polynomial is any function where you have a coefficient times a variable to a power being added to other coefficients times variables to other powers. These are polynomials. So examples of these would be things like x squared, or like something linear, like x minus 3 or 2x minus 3. These are examples of polynomials. And then, of course, more advanced ones, where you have something like, x to the fifth minus 4x to the fourth plus 3x squared minus 2. Like, these are all three just polynomials because they're just collections of coefficients times variables to powers being added or subtracted from each other. And so these are all polynomials. And so what we're going to talk about today is how do we take one polynomial and divide it from another polynomial, which it turns out the basic process behind it is similar to how you actually do it with division. The book uses this example, which I think is a good one. I'm actually going to do the same example. It says, what would I do if I did 178 divided by 3? And so this is a look back. It's important to note, and it doesn't always feel this way, but it's actually pretty true. Many different concepts in mathematics are built on the foundation of previous math. So if you understood perfectly how to do everything before what happened, doing the current stuff is easy, because it's just taking the new stuff and looking at it in a new way. But it's really just old information looked at in a new way. And so let's look back at how we divide numbers. Now, if you're reaching for your calculator, you're in trouble. You need to be able to look at this problem and ask yourself, how would I divide this without a calculator? Well, you might have learned it through this method. You put 178 inside a box, you put 3 on the outside, and you start dividing. Now to do this, the first thing we did was we looked for multiples of 3 to match our first term. So we looked at our first number and saw it was a 1, and we knew we can't make those match. 3 times 1 is 3, that's too big. So it's not there. 3 times 2 is 6, too big. 3 times 3 is 9, too big. So I can never get the 3 to go into the 1. But I can get the 3 to go into the 17. What you're looking for is the multiple that will get you closest to 17 without going over 17. So in this case, that number was 5. Because 3 times 5 is 15. Now, it was common to write it in this form because 3 times 5 is 15, and 15 is what we're going to take out of the first two numbers, which is 17. We would then take 3 times 5 and get 15, and then we would then subtract the result. So 3 times 5 is 15. We subtract that 15. 17 minus 15 is 2. We would then drop the 8, leading us to here. So we looked for multiples of 3 to match the first number. If that failed, we then looked at the second number and asked the same basic question. We wanted to go, this is what I call Price is Right rules, closest without going over. You want to get the closest you can without going over it. And what we do is we take the outer number times the top number. So we took 3 times 5 to get 15. And our next number is going to be what we have to take 3 times to get close to 28 without going over 28. So in this case, that's 9. 3 times 9 is 27. So we take 3 times 9 to get 27. And then we, of course, subtract the result. 28 minus 27 is 1. 3 can't go into 1, but it can go into a 0. Now, it was standard to go ahead and keep going, but for now, we're just going to stop right here. Once we get a decimal point, we're going to stop, because this is referred to as the remainder. The remainder is always this function that has a form that matches our particular values. So we have, as we can see here, the divisor, okay, the quotient, the remainder, and the dividend. So, in every problem, you would have a number on the inside called the dividend. You have the divisor on the outside. You have the quotient, which is on top, and then you have the remainder, which is the leftovers. So divisor, dividend, quotient, remainder. When we look at these problems, these two are typically what we start with. We are given the dividend, we are given the divisor. We finish with the quotient and the remainder. So in this particular problem, our divisor was 3. Our dividend was 178. Our quotient was 59. And our remainder was 1, I should say. You'll know you've done this right if your remainder is smaller than your divisor. That's always the case. It's kind of the last big piece. You keep going with these steps until eventually you run out of steps to do. So, if we look at this problem, the solution would look like this. We would say 59 and 1/3 as the solution. We have the quotient, 59, the remainder, and the divisor. So, quotient, remainder, divisor. That's how we write 178 divided by 3 is 59 and 1/3. Quotient, remainder, divisor. Now, all that's great. And I'll go through a second example before we go on. We're going to employ many of these same tactics to do an example that involves, non-numbers, polynomials. So, let's take a look now at some different numbers. Let's see. I'm going to make 2 up here. Let's go with taking 100. No, I don't like 100 anymore. Let's go 469. And I'm going to divide that by 12. Okay. So to do that, as we remind ourselves, this is the dividend. This is the divisor. Okay. Now, let's actually look at the problem. We have 469 and 12. Okay. 12 will not go into 4, so we look at 46. That's our first big term. 12 times 4 would be 48, but that's too big. It's too big. It's going over. So 4 times 3 is the next closest thing we're going to get. And 12 times 3, as it turns out, is 36. We subtract that result. So 12 times 3 is 36. We subtract the result, leaving us with 10. We drop the 9, leaving us with 109. And then we perform the same operation. Again, notice that 12 does not go into 10. It does not go into 1, does not go into 10, but it does go into 109. And it turns out it goes in there 9 times. 12 times 9 is 108. Subtract that result, leaving us with 1 left. And then we simply put the quotient, 39, the remainder over divisor, 39 and 1/12. This is how you do standard division when you don't have a calculator. And so again, you look for something to multiply to this term that we will then subtract from the overall term. So we took 12 times 3, getting 36, and we subtracted that from 46. We took 12 times 9, that was 108, we subtracted that from 109. And so each time you're looking to multiply and then subtract, multiply, subtract, multiply, subtract, multiply, subtract, until you run out of things to multiply and subtract, and that becomes your remainder. At this point, let's now look at a polynomial equation. Now, I'm going to pull some from the homework. I don't want to take away too many problems from your book, because the book can really help guide you on some of these. So I'm actually going to go to your homework problems, and I'm going to do, excuse me, let's look at a fun one. Let's do number 6. Actually, you know what? Let's do number 4. We'll do number 6 afterwards. Okay, so we have 2x squared minus 9x minus 5 divided by x minus 5. Okay, how are we going to write this? The exact same way we did before. So we have 2x squared minus 9x minus 5, and we have x minus 5. So, just like before, notice that some steps are not going to change. We're going to find a number to multiply up here that's going to be the closest we can get to our first term without going over our first term. That number, in this case, is 2x. If we take 2x times x, we are going to get 2x squared. It's the closest we can get without going over. Notice that if you do this correctly, it should always match, because that's kind of the point with polynomial division. That's the big difference, is that unlike before, where they rarely matched, right? We had 46, we got 36, close but not quite. We got 109, we used 108, close but not quite. But with polynomials, you should always be able to match perfectly. 2x times x is 2x squared. But because we're doing algebra, we have to make sure to distribute. If we're going to take 2x times x, we have to also take 2x times negative 5, or negative 10x. So, where did this row come from? We took 2x times times x minus 5. So we took 2x times x minus 5. Now, we then have to subtract everything, meaning this entire term gets subtracted, meaning you have to make sure to distribute. This becomes a negative 2x. This becomes positive 10, and then we put them together. Notice it seems weird, but it is no different than we did with numbers, right? 3 times 5 is 15, yet we're subtracting the 15, right? 3 times 9 is 27, yet we're subtracting the 27. 3 times 12 is 36, but we're subtracting 36. 12 times 9 is 108, but we are subtracting 108. 2 times x is 2x squared, but we are subtracting 2x squared. Negative 5 times 2x is negative 10x, but we are subtracting negative 10x, becoming positive 10x. And as like before, the nice thing is these first ones should cancel, leaving us with negative 9x and positive 10x would be x, and then minus 5. Okay. Now, just like before, we have to find something to multiply. We have to find something to multiply to get it to match. Well, in this case, that's a 1. 1 times x is x. 1 times negative 5 is negative 5. Notice that these two have to match perfectly. What happens with these two is inconsequential. It does not matter. These two should match perfectly, otherwise you've done something wrong. And again, make sure you distribute. 1 times x is x. 1 times negative 5 is negative 5. So this was 1 times x minus 5. So we took our quotient times our divisor. Okay, let's do this. Now, from here, we subtract. That would make this a negative x and a positive 5. Negative x is 0, positive 5 and negative 5 would be 0. That's good. Since there's no remainder, turns out this is our answer. So our answer is 2x plus 1. It is possible when doing a division problem that you end up with no remainder, in which case you just write your quotient as your solution. Let's compare this now to number 6. Number 6 is, I don't believe, quite as nice, but we'll see. So we have 4x squared minus 10x plus 6 divided by 4x plus 2. Okay, just like before. 4x squared minus 10x plus 6 is the dividend. 4x plus 2 is the divisor. My goal is we're going to multiply numbers to the divisor until we match to what's inside the dividend. So, in this case, my number up here is going to be x. Why x? Because x times 4x is 4x squared. They match, which is the key thing here. But I have to make sure to distribute. I take x times 2, which is positive 2x. So again, we took 4x plus 2 times x to get this line. Now we subtract, just like we did with the numbers. 4x and 4x, when subtracted, go away. So it becomes negative 4x, this becomes negative 2, which is perfect. So this becomes negative 12x plus 6. That looks pretty good. Now again, my goal is to get these two to match. So I have 4x, I want to get to 12x. I need to multiply, again, it's always multiplication. I need to multiply by negative 3. So if I take negative 3 times 4x plus 2, here's what I get. I would end up with negative 12x minus 6. Looking good so far? So, I want to then subtract everything. So, subtraction. The double negative would make this positive, double negative would make this positive. Negative 12 and positive 12 should cancel, as they always should. The first term should always cancel. 4x squared cancels. Negative 12x cancels. But now we have 6 and 6 for a total of 12. And so this is our remainder. If the question asks for the remainder, it's just 12. So, in this case, the question said, so if I read the instructions, specify the quotient and the remainder. The quotient would be x minus 3. The remainder would be 12. If it said just to write the solution, it would be x minus 3 plus 12 over 4x plus 2. The best way, in my opinion, to get used to these kinds of problems is do a lot of them. So let's look at number 8. Number 8, we have, this is the first one where we have a trick. Okay. I'm going to go ahead and start shorthanding some of this because I don't need to write down all these steps. So we have negative x squared minus 1. So again, my function was, here we go. So negative x squared minus 1 divided by x plus 1. Here's the thing. You'll notice that this has a piece that is missing in my order. Like this one went x squared, x number. X squared, x number. It turns out that always has to happen in order for this to simplify properly. So since there are no x's in here, I need to indicate that inside of my dividend. So if I have negative x squared, I have to say it has 0 x's. Otherwise, when I try to combine them like I did up here and like I did up here, it's not going to work very well. This step is crucial. And if I'm looking at my notes, it's the next thing I should add. When dividing, any skipped terms become zeros. Any skipped terms need to become zeros and need to be included. So in other words, like on this one, I'll use it as my example, negative x squared minus 1. We need to rewrite this as negative x squared minus 0x, or even plus 0x minus 1. We need to do this step if we want to divide it successfully. Yes, that is an acceptable answer. So is this, and this one's easier to divide. You will make far fewer mistakes if you do it this way. Okay. Well, let's do it. So I got my dividend. Now I need my divisor, which is x plus 1. Okay, let's start doing it. My goal again is to get the first term to match the first term. So x to become negative x squared. Well, how do I do that? Well, I'd use a negative x. I take negative x times x plus 1. My goal is to get them to match. Negative x times x would be negative x squared. Negative x times 1 would become negative x. Okay, not too bad. All right, next, I now need to simplify. So then I subtract that result, which we need to distribute the negative sign. This becomes a positive, this becomes a positive, and if I did this correctly, these first two should disappear, becoming a 0. Whereas if I have 0x and I add another x to that, I just have a single x left behind. I drop the negative 1, just like I do with regular division. Now again, my goal becomes, I want to match x to x. How do I do that? Multiplying by 1. Remember, multiplying by 1 doesn't do anything. It just creates the same terms. So we take 1 times x plus 1. Remember, we always take quotient times divisor. Negative x times x gives us negative x squared minus x. Positive 1 times x plus 1 gives us x plus 1. And then we subtract, meaning this becomes negative and that becomes negative. So negative x and positive x becomes 0. Negative 1 and negative 1 becomes negative 2. So the question asks, what's my quotient? Well, my quotient is negative x plus 1. It asks what my remainder is. My remainder is negative 2. If it asks for the solution is negative x plus 1, and then I like to write minus 2 over x plus 1. So it's still a negative 2, it's just written as a minus sign instead of a negative sign, which I like a lot more. And so, for this first few problems, this is what you're asked to do. It's to do simple, basic long division. Note, long division works no matter how big or how small your terms are. And so here's an example of one where we have a larger first term, and it doesn't really change what's going to happen. I'm going to use a textbook to illustrate this. I think it's right here. Wow, the text doesn't give one. That's so weird. Usually it's right here. Okay. So this is referred to as a divisor algorithm. It's exactly what I just showed. It's that you can always split these apart into these pieces. Nope, that's essentially what we just did. This is a great example to go with. Notice how they list out all the pieces here. This is nice. They write out the divisor, which is what you're dividing by, 3x minus 2. The dividend, which is the original problem. The quotient, which is what ends up on top. The remainder, what ends up on bottom. If it's a remainder of 0, we usually just don't write a remainder. We just skip it. Okay. I guess I could just make one up real quick. So that's what I'll do. This is not in your homework for tonight, but it's just an application of what is in your homework. So let's go ahead and take a look at it. So this is just an example. What if we had a bigger number for our divisor? So let's use, 2x cubed minus 3x squared plus 4 divided by x squared plus 1. Coolio. Well, first off, very first thing I'm going to do is I want to rewrite this. I want to write this where any terms that are skipped, remember, any skipped terms become zeros. So if I have any gaps in between my powers, I need to put a 0 in there. Well, with this one, I would have 2x cubed minus 3x squared plus 0x plus 4. No matter which term is skipped, include it in as a 0. Now, I do my problem. Outside, x squared plus 1. Inside, 2x cubed minus 3x squared plus 0x plus 4. Okay. My goal, remember, is to make my first term match the first thing on the inside. So I can do it in two pieces, the coefficients. I have a single x, I want to get 2 x's, so I multiply by 2. I have an x squared, I want to get x cubed, so I need one more x. Notice again how we do that. Numbers. So I have a 1, I want to get to a 2, multiply by 2. I have an x squared, I want to get x cubed, just need another x. And so this line becomes x squared plus 1 times 2x. Now, when I multiply this through, I want to make sure to line them up. So when I multiply this through, I'm going to get 2x cubed as my first term, but 2x times 1 is just 2x. I don't want to put that here with the x squareds because they don't go together. It's an x squared term. I can't put x's and x squareds together. I need to put the 2x with the other x's right here. Meaning just like before, I end up having a 0. If there are any, I can't stress enough, any skipped terms become zeros. There's a skipped term here, so it became a 0. So I take this function and subtract it. So 2x cubed minus 2x cubed is 0x cubed. That was the goal. Negative 3x squared minus 0x squared is negative 3x squared. 0x minus 2x would become negative 2x, and then the 4 drops down, becoming a 4. Okay. Okay, I want to get my first term to match my first term. So I have x squared. I want to become negative 3x squared. How do I do that? By minus 3. So we take negative 3 times x squared plus 1. Negative 3 times x squared would become negative 3x squared. They matched. I know I'm good. Negative 3 times 1 would become negative 3. That's good. Separate them out. No middle term. And then we subtract. So double negative would make this positive. This is 0, so it doesn't matter. This becomes positive. And now we put them together. Negative 3x squared plus 3x squared becomes 0. That's good. Negative 2x minus 0 is 0. 4 and 3 together make 7. The big part here is making sure to distribute the negative signs. That's a big detail. So if I'm looking at my notes, make sure, so this is trick number 1 that you're going to have problems with, is when dividing, make sure any skipped terms become zeros. Number 2, make sure to distribute. Make sure to distribute both the negative and what you multiply. Big one there. Make sure to distribute both. So like in this problem, I have to take 2x times x squared, but I also have to take 2x times 1. I have to take a negative times negative 2x cubed. I have to also take a negative times the 2x. So I end up with a negative sign here, negative sign here, negative sign here. That's why it becomes negative 2 here. That's why these two cancel. Okay? Now, you'll notice there is no way to make x squared become negative 2x. The power on the outside is higher. This tells me that this is the remainder. And so, if the question asks, what's the quotient? I want to use Q as quotient. The quotient would be 2x minus 3. What's the remainder? The remainder would be negative 2x plus 7. Note these two look really similar, but look at how the answer is written. I'm going to do it right here. We would do 2x minus 3 plus negative 2x plus 7 over x squared plus 1. The solution is quite different. So quotient, remainder, solution. Just different versions, all containing similar pieces of information. That's the first kind of problems we have tonight, is these long division problems. I like them. I enjoy long division. I think it's one of the more fun things you can do in this kind of class. But that's because I like math. Let's now look at the kind of opposite of long division, which is referred to as synthetic division. Synthetic division is a shorter, faster way to do long division. However, on the other hand, it is also limited in how it can be used. It is very limited in how to use it. It can only be used when it is of the form x minus k. So if we look back at the problems we've already done, in theory, on number 4, we could have used synthetic division instead of long division, because it's x minus 5. In this case, my k would be 5. But on number 6, that's not possible, because we have 4x plus 2. That 4 gets in the way. It's not possible to do synthetic division directly with this method. Same thing on number 8. 8 could do it because we have a 1. In this case, my k would be negative 1, because remember, it's negative k in the formula, so if it's plus 1, it would have to be negative 1. Whereas in this example, it can't be done at all because notice it's x squared plus 1. This requires k and x by itself. So synthetic division is very, very, very limited. But synthetic division is a faster and easier way to write them. And many people like synthetic division compared to long division because if you look at this, there's a lot of writing with long division. It's got a lot of pieces to it. Has a lot of parts floating around. It's a lot harder to do it. At this point in time, let's talk about synthetic division. Now, I think your textbook does a pretty decent job explaining where synthetic division comes from. I am not the best at explaining synthetic division. So what it's going to do, I'm going to use this example to kind of showcase how synthetic division works and use it to get to a solution here. So, in this example, you notice a couple of things. Number 1, the first thing I want you to see is that in this problem, we are clearly taking 2x squared. I'm going to zoom in a little bit. 2x squared plus x plus 18. 2x cubed minus 3x squared plus 4x plus 5. That's our original dividend. We are using x plus 2 as our divisor. And notice the first step was we take 2x squared times x to get 2x cubed, 2x squared times 2 to get 4x squared. The first two terms match, which is how we know we've done it right. And then we subtract. Notice we subtract both pieces, so it becomes negative 2x squared and negative 4x, just making sure to distribute. And negative 3x and negative 4 becomes negative 7x squared. Drop the 4x down. X, oh, there appears to be something missing here. So here, there should be a 7 here. If we take 7 times x, we get 7x. That's so weird. Ah, there's an error in your textbook. Ha 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 ha. I love finding errors in the textbook. This should be minus 7x. And in fact, if we look down here, it actually is minus 7x. But we'll get to that in a second. We put a negative 7 here. Negative 7 times x would be negative 7x squared. Negative 7 times 2 would be negative 14x. We then negate everything. So negative times negative would make this positive, canceling these two. Negative times the negative would make this positive. 4 and 14 together would make 18. We have 18x plus 5. We then do 18 times x, get 18x. 18 times 2 to get 36. Subtraction for both of them. We get with negative 31. This is how I would do a standard problem. And so I don't like the fact that they've done this problem wrong, so I'm going to copy my own version. So we take inside 2x cubed minus 3x squared plus 4x plus 5. On the outside, we have x plus 2. All right, so our first thing, in order to get the x to become 2x cubed, we multiply by 2x squared. 2x squared times x would become 2x cubed. 2x squared times 2 would become 4x squared. We make sure to subtract, which means this first one becomes negative and the second one becomes negative. Negative and positive ends up canceling. Negative 3 and negative 4 become negative 7x squared. Drop the 4 down, so plus 4x. What's the next thing that happens? Well, we want to make x become negative 7x squared, so it would be negative 7x. So x times negative 7x would become negative 7x squared. They match. That's perfect. Negative 7x times 2 would become negative 14. Note you have to make sure to distribute. Negative 7 times 2 is negative 14. X times 1 is x. And then we subtract. When we subtract, this becomes a positive. This becomes a positive. These two cancel. 4 and 14 together makes 18. X. Then we drop the 5. Okay, I want x to become 18x. How do I do that? Multiplying by 18. Again, we take each term and multiply it to get to the next line. So 2x squared times x becomes 2x cubed. Negative 7x times x becomes negative 7x squared. 18 times x becomes 18x plus 36. We subtract. We know we've done it right if the following happens. Negative, negative. These two have to cancel. And 5 and negative 36 becomes negative 31, meaning I have a quotient of 2x squared minus 7x plus 18. I have a remainder of negative 31. And my solution is 2x squared minus 7x plus 18 minus 31 over x plus 2. Now, synthetic division, the idea of it is to take all this same information and condense it down into something a little tighter, a little neater. Now, how it does so is as follows. What it's going to do is inside of this little box we're going to make, we're going to put the coefficients of the dividend. So for this problem, we have 2, negative 3, 4, and 5. So we're going to put 2, negative 3, 4, and 5. So we take the coefficients, 2, negative 3, 4, 5, 2, negative 3, 4, 5. And then outside, we are going to put the negative of the k. So if this is plus 2, we're going to put minus 2. So again, if we have x plus 2, this becomes negative 2. If we had another problem where it was like x minus 5, then we put a positive 5. It has to be in this form. Now, how does synthetic division work? Well, the first number is dropped. So, step 1, we're going to drop the first. So the 2 is just a 2. Then you're going to multiply k times the first and add to the second. So you're going to take negative 2 times 2 and get negative 4. So we multiply k, make this stand out here, multiply k, that's that number outside, and the first, and add it as a second. So we take negative 2, so we multiply this by negative 2, and we get negative 4. And then we're going to add these together to get negative 7. We are then going to keep following that pattern. We're going to multiply by negative 2, Negative 7 times negative 2 would become positive 14. And then we're going to add these together. 4 and 14 together makes 18. We're then going to multiply by negative 2, which would become negative 36. We're then going to add and get negative 31. You'll notice, if you're perceptive, that these are the coefficients of the solution. 2, 2, negative 7, negative 7, 18, 18. And it has even given us the remainder. So the last number is always the remainder, and then these two become, so hold on, repeat until the end. This will become 2x squared minus 7x plus 18 as our quotient. Notice how much space this version takes up versus this version. It's so much easier to do synthetic division, and it takes up a lot less space. Despite, if you notice very carefully, all the same math is done. That's a big detail that people tend to miss, and I want to point that out real quick. Notice where these numbers come from. The 2 and the negative 4 are actually right here, 2 and 4. It's just when we put them together, they become negative 7. The 14 is right here. The 36, the negative 36, is right there. And so, all the same math is eventually done. This is just a very concise and consolidated way to do it. Let's look at some homework problems. Problem like, let's just go straight to 14. Now, I will use these last one as an example to kind of showcase how to do it. So again, I'm going to, I'm going to drop the first number. First, I'm going to make sure to write it in the correct form. Then I'm going to drop the first number, multiply k times the first number, and add it to the second, and keep multiplying k times the number and adding it to the next number until I run out of numbers. So, let's look at 14. On 14, my problem is 3x cubed minus 2x squared plus x minus 4 divided by x plus 3. Big first step in synthetic division is making sure to write it correctly. So, let's write it down. I have my k. If my original problem is x plus 3, then my k is going to be negative 3. So the positive 3 becomes a negative 3. My numbers inside would be the first coefficient, 3, second coefficient, negative 2, third coefficient, 1, because it's a single x, and then negative 4. This first step is key. You must make sure to copy it down correctly, or else it makes no sense in how you're able to get to a solution. And this we'll do is number 20, I think. Okay. Let's do the math. First thing that happens is we drop. The 3 drops and stays a 3. Next thing happens, we take that 3 times negative 3. Negative 3 times 3 would become negative 9. Negative 9 and negative 2 together makes negative 11. We multiply this by negative 3. Negative 3 times negative 11 would become positive 33. Add those together. 1 and 33 together makes 34. Okay, so we take 34 times negative 3, and 34 times negative 3 would become negative 102. Add those together, we should get negative 106. Which means my solution would be 3x squared minus 11x plus 34. This would be my quotient. My remainder would be negative 106. My solution would be 3x squared minus 11x plus 34 minus 106 over x plus 3. Now, just to reiterate this point, I'm going to do this problem again. I'm going to repeat 14 with long division. I have not asked you to do this. That is because, well, it's stupid. And secondly, because even once you do it with long division, you're going to get the exact same result if we did this correctly. So let's prove it. Exact same problem now. 3x cubed minus 2x squared plus x minus 4 divided by x plus 3. All right, let's do this. I'm going to do it pretty quick, so make sure you're following along. I would use 3x squared. 3x squared times x would become 3x cubed. 3x squared times 3 would become plus 9x squared. We would then subtract the whole thing. Distribute the negative becomes negative 3x. Distribute the negative becomes negative 9x squared. This becomes negative 11x squared, which you'll notice is right here. To get these to match, I'd have to take it by negative 11x. Negative 11x, make sure you drop the x. So plus x. Negative 11x would become negative 11x squared, negative 33x. I would then subtract the whole thing. So double negative, this would become positive 34x minus 4. And then, of course, we would use plus 34. So you notice right here, 3x squared, negative 11x, plus 34, plus 34. Last thing is to make sure I get negative 106. So take 34 times x would become 34x. Run out of room here. 34 times 3 would become positive 102. We then subtract the whole thing. 34 negative, this becomes negative 106, exactly as we expected. And so, yeah, it's just which one's more work, which one's easier. Like, it took me more work to show the solutions than it did to write the problem. Like, it's the nice thing about synthetic division. Okay, number 20. Okay, on number 20, we have, so, no problem, negative 6x cubed plus x squared minus 4 divided by 2x minus 3. Okay, first things first. I want to make sure to copy it down in here correctly. Well, I have negative 6, positive 1, but you might notice that it goes from x squared to 4. I don't know how many times I'm going to have to bring it up, but I will bring it up again. Anything that's skipped is turned into a 0. Anything skipped becomes a 0. So if x is skipped, this means there are 0 x's. And then, of course, negative 4. Now the question then becomes, what do I put out here? Now, when it was x, I just put, x plus 3, I just put negative 3. It turns out I cannot do the same thing here, because it is 2x minus 3. So the question becomes, what do I put on the outside? To find out what goes on the outside, the easiest way is to solve a very simple problem. Take the outside and set it equal to 0. So we'd add 3, divide by 2. So the outer number should be 3/2. It turns out that actually works over here too. If this is x plus 3, we would do x plus 3 equals 0. Subtract 3 from both sides. X equals negative 3, and guess what? That's exactly the number we got. Even on the previous problem where we had things like x plus 2, right? Previous problem, what we did was we just take x plus 2, set it equal to 0, solve, we get x equals negative 2, and that's what k is. So this is one of those shortcuts that's super helpful. So note this shortcut. I will even add that to my notes. If you're doing synthetic division, if you are not in x minus k, set equal and solve to find k. So if we have, 3x plus 4, if that's what we're dividing by, so in the problem, let's just make one up quick. So 3x to the fourth plus 6x cubed minus 7 divided by 3x to the fourth. So if we have a problem like this, to find out what k is, we just take, to find k, we're going to take 3x plus 4 and let it equal 0. And then solve. Subtract 4 from both sides. Divide by 3. This is our k. And so this is a quick and easy way to always figure out what k is, even if it's not necessarily in the right form. So, from here, let's now solve this problem. Get all the pieces. Let's do it. So, as before, we're going to drop the negative 6. And it's going to just be negative 6. We're then going to multiply by 3 halves. So, negative 6 times 3 halves would become negative 18 over 2, which is negative 9. Some quick math is helpful here. So I said your basic math skills are what's going to hold you back in this section more than anything else. 1 and negative 9 makes negative 8. Okay. 3 halves times negative 8. Do 3 halves of that. 3 times negative 8 would become negative 24. Divided by 2 is negative 12. So this would become 0 and negative 12 makes negative 12. We then do this times 3 halves again. 3 halves times negative 12. This would become positive 18. And negative 4 and positive 18 makes positive 14. Now, let's make sure to write my solution. So my answer, if it asks for it for quotient and remainder, let's go each. The quotient would be negative 6x squared minus 8x minus 12. The remainder would be 14. If it just asks you to solve, then the solution would be negative 6x squared minus 8x minus 12 plus 14 over the original, which was 2x minus 3. I'll do one more before I finish, but this is the basic format for tonight. Note each time how we do these pieces and these parts. It's the same basic components every single time. Okay. I'm going to look at number 36. Okay, our last big one. Okay, 36 is the following problem. 4x to the fourth minus 2x cubed minus 4x plus 2 divided by 2x minus 1. Okay, let's do one piece at a time, okay? First, let's copy this down. 4, negative 2. 4, 3, I don't have a power of 2, so there's a 0 in here. Then we have negative 4 and 2. Okay, now what number goes on the outside? I don't have it in the right form, so I do 2x minus 1 equals 0. Add 1 over, I get 2x equals 1. Divide by 2, x equals 1 half. So my error number should be 1 half. Now I follow my steps. I'm going to do it all in one color this time because I'm getting tired of switching. So drop 4. Multiply 4 times a half is 2. 2 and negative 2 makes 0. Ooh, that's nice. 0 times a half is 0. Okay. Add those together. 0 and 0 together is 0. 0 times a half is 0. This can happen. Okay. It's possible to get zeros in the middle, and we'll talk about what that means in just a second. Negative 4 and 0 makes negative 4. Half of negative 4 is negative 2. Negative 2 and 2 is 0. So what's this mean? Remember, we started with a power of 4 this time. This would become 4x cubed plus 0x squared plus 0x minus 4. The remainder in this case would be 0, or there's no remainder. Now, if it asks for the solution, there's another way to write this. This would be, so the zeros don't mean anything, so this becomes 4x cubed minus 4. And it turns out the solution is 4x cubed minus 4. Because there's no remainder, I can just leave it off. And that's the solution. Pretty cool, right? There's one more part to your homework that we did not discuss, and it's what happens whenever it asks it in graphical form. In this case, if you're given the graph, where I put it, there we go. So last piece of your notes. If you're given a graph, your k is just your x-intercepts. Last big part of your notes there. If you're given a graph, your k is your x-intercept. So in this example, negative 1 is going to be my k, because negative 1 is the number that I would use as my x-intercept. On this example, well, this is not odd, so I'll skip it. On this example, 2 would be what I plug in. So I plug in 2 and get an answer. On this example, negative 3 would be my k. So I'd use negative 3 as my k in synthetic form. And that looks to be it. Okay? That's it in its basic form. Whew, 1 hour. It's a long assignment, but it's got a lot to it. A lot of this should be reviewed from Algebra 2, but it's highly possible that you don't remember much from Algebra 2. And if not, well, hopefully this will be a nice assignment for you. Just to remind ourselves of our homework assignment tonight. I had 2 pages of notes dealing with synthetic and long division. Your assignment, page 400/418, 1 through 53, every other odd. That'll be it for today. I'll talk to you guys tomorrow. Have a good rest of the night.